One Australian farmer was told to quit. His land was cracked, his topsoil was gone, and every government agronomist who walked his paddocks told him the same thing. The land was finished, and so was he. He ignored all of them, put down his chemicals, stopped turning the soil, and did something so strange that his neighbors openly laughed at him. What grew back didn't just save the farm. It rewrote what Australian agriculture thought it knew about grass, soil, water, and the relationship between a farmer and the land beneath his boots. What was at stake Australia was not always this dry and broken. Before European settlers arrived with their cattle, their sheep, and their absolute confidence that they understood how land worked, the grasslands of southeastern Australia were something extraordinary. Deep-rooted perennial grasses stretched from horizon to horizon, some with root systems dropping 3, 4, 5 meters into the ground. The soil was dark and spongy, absorbing rain the way a sponge absorbs water. Slowly, completely, holding it underground for weeks and months, and releasing it in a slow, steady trickle that fed creeks and springs through the dry season. The land teemed with life nobody counted. Thousands of species of beetles, moths, and soil invertebrates lived in a single hectare. Native kangaroo grass and wallaby grass covered the plains in a mosaic that shifted with the seasons and the rain. Brolgas danced on the floodplains. Quolls moved through the undergrowth. The soil itself was a living system, woven through with fungal threads and bacterial communities so complex that scientists today are still mapping them. Before European boots touched this ground, it was one of the most productive dryland ecosystems on Earth. Nobody in London knew that. Nobody particularly asked. European settlers brought a different philosophy with them. The logic seemed unassailable. Clear the land, run stock, harvest grass, repeat. And it worked, for a while, the way things that are slowly destroying themselves always do. By the early 1900s, the great grasslands were already thinning. Annual grasses replaced perennials. Deep root systems disappeared. The soil compacted under hooves and hardened under the sun until it shed rain the way a tin roof sheds rain. Fast, complete, and useful to nobody. By the 1980s, large stretches of New South Wales looked nothing like what the first settlers had described. Salt scalds spread across paddocks where shallow water tables wicked salt to the surface. Bare ground baked between sparse, drought-stunted pasture plants. Topsoil blew off in red clouds on hot north winds. Streams that had run year-round through living memory now ran brown, with sediment for 2 weeks after rain, and then dried to sand. Farmers were spending more on fertilizer and chemicals every decade, fighting harder and harder to maintain yields that were quietly, year by year, going nowhere good. The land was not simply tired. It had been systematically dismantled, piece by piece, with the best available equipment and the best available advice. And the people doing the dismantling had absolutely no idea. That is not a comfortable thing to write, and it probably isn't a comfortable thing to read. But it is the only honest starting point for what happened next. The man who broke his own farm. Colin Sayers grew up on Winona Station in New South Wales. His family had farmed those paddocks near Goolgong in the central west of the state since the early 20th century. He knew the land the way you only know land when you have walked it since childhood. Its dips and rises, its wet corners, its hard-pan ridges where nothing ever seemed to thrive no matter what you planted or how much you spent trying. He farmed the way he had been taught to farm. He ran sheep, grew cereal crops in rotation, and cultivated the soil before planting, turning it over to create a clean seedbed, killing the weeds, starting fresh each season with bare dirt and good intentions. The extension officers approved. The bank approved. The yields were acceptable. The land, beneath the surface where nobody was looking, was slowly and quietly falling apart. Then, in 1979, a catastrophic bushfire came through. It burned everything. The fences, the pasture, the crops, the sheds, gone. The fire took the farm back to bare black earth and left Colin Seas staring at what remained of 30 years of family work. If you have ever watched something you built burn down, you understand the particular combination of grief and strange, enforced clarity that follows. You have to decide what to rebuild and what you no longer believe in enough to rebuild. It is a brutal way to get perspective. It is also a remarkably effective one. Nature answered before Colin did. In the months following the fire, something unexpected appeared in the burned paddocks. Native perennial grasses came back. Not the tame, introduced varieties he had seeded for decades, but the originals. Wallaby grass, weeping grass, red grass, pushing up through the ash in vigorous patches wherever they had survived underground in seed or root. They were fast and dense and growing exactly where Colin had planned to plant oats. He planted the oats anyway because a man has to eat. But he watched what was happening beneath the crop canopy. The native grasses and the cereal crop were growing together, side by side, in the same paddock at the same time. Not competing the way the textbook said they should. Not choking each other out. Just coexisting, apparently without reading the relevant literature on why that wasn't supposed to be possible. The fire had, accidentally, run the most important experiment of Colin Seas's farming life. He just didn't know it yet. The question nobody was asking. The observation nagged at him for years. Conventional agriculture had a clear and settled answer to the grass and crop question. You couldn't have both. You killed the pasture. You planted the crop. You harvested the crop. You replanted the pasture. That was the system. It had been the system since the first mechanized plows broke Australian soil, and challenging it was not the kind of thing a farmer did if he wanted to be taken seriously at the local agricultural show. Colin started talking to Darrell Clough, an ecologist who had spent years studying native perennial pastures in New South Wales. Darrell was one of those people who had noticed what everyone else had stopped noticing, that the native grasses were not weeds to be eliminated. They were the original operating system of the land, a system that had been running, debugging itself, and improving for thousands of years before a single European plow broke a single Australian paddock. The grasses knew things. They had figured out drought and flood and poor soil and grazing pressure over millennia. And Australian agriculture had spent a century trying to replace them with something inferior. Together, they started asking a different question. What if the separation of crop and pasture was not a biological necessity, but just a habit? What if the reason nobody grew crops into living grass wasn't that it couldn't work, but simply that nobody had tried it with the right species, the right timing, and the right restraint? This was, to put it mildly, not the kind of question the agricultural establishment welcomed. Farmers who asked questions like this were politely redirected toward approved extension materials and encouraged to attend the appropriate field days. Colin had the considerable advantage of not caring what people thought. This is genuinely underrated as a farming quality, possibly as a human quality. He decided to try it on his own land, at his own risk, with no institutional backing and no guarantee it would work. The idea they landed on was simple enough to explain in a sentence and complicated enough to take a decade to properly understand. You plant cereal crops directly into living perennial pasture without spraying the grass out first, without tilling the soil flat, without starting from bare ground. You let them coexist. The grass stays. The crop goes in on top, and you do not touch the soil underneath. The method that made no sense. Pasture cropping sounds deceptively simple. Plant the crop into the living grass, rest the stock while the crop establishes, graze it after harvest, repeat. In practice, every single step violated something that conventional Australian agriculture held as fundamental truth, And that violation was precisely the point. Conventional grain farming in Australia begins with bare soil. You knock down the pasture with herbicide, cultivate the ground, create a clean weed-free seedbed, and give the crop the best possible start by eliminating every competitor. The logic is simple, and, in a narrow single-season sense, it works. The problem, and it is a problem that took decades to fully understand because nobody was measuring the right things, is what you destroy in the process. Bare soil is not a clean slate. It is a graveyard, and the things dying in it are the things that make farming possible in the first place. When you remove the living root system from a paddock, the underground ecosystem collapses. Mycorrhizal fungi, the threads that connect plant roots to soil nutrients, that move water through dry periods, that allow plants to share resources in ways that still make scientists slightly uncomfortable at dinner parties. Those networks break down within weeks of the roots disappearing. The bacteria that cycle nitrogen into plant-available forms lose their food source and their populations crash. The earthworms, which require organic matter and living roots to survive, retreat or die. Within a single season of conventional tillage, a paddock can lose decades of accumulated soil biology. One season. Decades gone. Pasture cropping doesn't do any of that. The living roots stay in the ground. The fungal networks keep running. The soil biology keeps eating, cycling, and reproducing. The cereal crop, typically oats, wheat, or triticale, is planted in the cool season when the warm season perennial grasses go dormant. It grows up through the living sward rather than replacing it. The grasses are not competing because they are asleep. And when spring comes and the grasses wake up, the crop is already tall enough to hold its own. The timing is everything. Get it right, and you have a crop and a pasture. Get it wrong, and you have a paddock full of regret. The logic only seems counterintuitive until you understand what soil actually is. It is not a growing medium. It is a community, built over thousands of years, maintained by billions of organisms per handful, that feeds plants from below in ways that a bag of synthetic fertilizer can only partially and temporarily replicate. Colin Sayce was not replacing the system. He was working with the system, for the first time in decades, on that land. And the sheep, always the sheep, were the key to closing the loop. Planned rest periods gave the pasture time to recover between grazing events. When the stock returned, they grazed the post-harvest crop residue and the recovering grasses, cycling nutrients back into the soil in the most efficient possible way. No part of the system was wasted. Nothing was ever left bare. The land never got the chance to fall apart because something was always alive in it, always feeding it, always holding it together. The numbers that defied the models. The results at Winona Station were not subtle. Scientists are trained to be careful with words like extraordinary, but the data from Colin's paddocks made careful language genuinely difficult to sustain. The changes were not incremental improvements on the existing trajectory. They were a completely different category of outcome from what conventional farming had been delivering. Soil carbon at Winona doubled over 15 years. This matters far beyond the soil health conversation. Carbon in soil means water retention, biological activity, and resilience during drought. The three things an Australian farmer in New South Wales needs most and can least afford to lose. In conventional paddocks across the region, soil carbon had been declining for decades as tillage and bare fallow exposed organic matter to oxygen and heat. At Winona, it was moving in the opposite direction, building steadily the way it builds under undisturbed grassland. The paddocks were getting richer, not poorer. That had not happened in that country for a very long time. Native plant diversity exploded across the paddocks. 6 species of native plants had been recorded at Winona when pasture cropping began. Within a decade, researchers counted over 40. 40 species returning to paddocks that had been under conventional management for most of the 20th century. Species that had survived as seeds underground, waiting with a patience that makes human planning look slightly embarrassing, for the tillage and the herbicide to stop so they could come back. They had been waiting for decades. The moment conditions allowed, they came back within years. The water infiltration data was the number that made hydrologists put down their coffee and read it again. Conventionally managed paddocks in the region absorbed around 5 millimeters of rain per hour before runoff began. Winona's pasture-cropped paddocks, with their intact root systems and living soil biology, absorbed 500 millimeters per hour, a 100-fold improvement. Rain that used to run off Collins' property and flood the creek downstream now soaked into the ground within meters of where it landed. The land was no longer shedding water. It was drinking it. And then the sheep. The original question, the one that makes every farmer in the room lean forward when you tell this story. Collins says doubled his sheep numbers without adding a single extra hectare. Not by overstocking and crashing the system, but because the land itself became genuinely more productive. More grass, more species, more diversity, more resilience, more carrying capacity, year after year. The experts who had walked those paddocks and declared the land marginal were looking at the same dirt. They were simply looking at it with a framework that couldn't see what was actually happening underneath it. The soil nobody could see. Below the Winona paddocks, something was happening that nobody could photograph or easily explain to a journalist. The underground revolution was, in many ways, the most important part of the entire story, and it was completely invisible from the surface. This is, historically, how the most important things tend to work. Earthworms came back first. This sounds small. It is emphatically not small. Earthworms are ecosystem engineers at a scale that makes the word modest seem laughably insufficient. Their burrows aerate soil, drain water, and create channels that roots follow deep into the profile. Their castings are the most nutrient-dense material in any paddock, a slow-release fertilizer produced for free by animals that ask nothing in return, except that you stop poisoning them. Under decades of conventional tillage and chemical application, earthworm populations at Winona had been devastated. Within a few years of pasture cropping, the worm counts were rising, then rising faster, then reaching levels that researchers hadn't documented in New South Wales agricultural soils in living memory. The mycorrhizal fungi returned along the living root networks that the perennial grasses maintained year-round without interruption. These fungi are, in the most literal biological sense, the internet of the soil, a system of hyperfine threads connecting plant roots across the entire paddock, transporting phosphorus toward roots that need it, moving water through dry patches, carrying carbon compounds between plants in ways that allow the whole community to function as something closer to a single coordinated organism than a collection of competing individuals. When you till, you shred that network completely. When you stop tilling, it rebuilds. At Winona, it rebuilt. And as it rebuilt, the paddocks above it changed in ways that soil carbon measurements and species counts only partially captured. The water cycle transformed underground as completely as it transformed at the surface. Living roots create channels, and the soil biota around those roots creates aggregates, clumps of soil particles bound by fungal threads and bacterial secretions that give soil its sponge-like structure. That structure is precisely what allows 500 millimeters of water per hour to disappear into the ground rather than run off the surface. It is not the soil type that determines infiltration. It is the biology inside the soil. Destroy the biology, lose the structure. Restore the biology, and the structure comes back, along with everything that structure makes possible. What this meant for the broader regional water cycle was significant. Collins' property was not an island. Water that soaked into Winona recharged the groundwater that fed springs and creeks on properties downstream. The hydrology of his corner of New South Wales was quietly, measurably improving. One farm. The neighbors weren't doing anything differently. The creek didn't care. What the experts got wrong, The agricultural establishment in Australia did not embrace pasture cropping immediately. This should surprise absolutely nobody. Established systems, and the institutions built to support them, do not typically respond to a sheep farmer in Gulgong saying he's found a better way by immediately agreeing that yes, indeed, he has. There were meetings. There were papers. There were politely skeptical agronomists who used phrases like interesting but preliminary and further investigation required, which in institutional language means we are not ready to admit this yet. The core assumption that had to fall was the one about bare soil. Conventional cultivation rests on the belief that a clean, bare seedbed gives crops the best possible start. And in a narrow, short-term, single-season sense, it genuinely does. The crop going into a cultivated bare paddock does have less competition in its first weeks. The problem is what that bare soil costs over 10 and 20 and 30 years, costs that never appear in a single season's yield data but accumulate steadily in the soil carbon figures, the water infiltration rates, the earthworm counts, and the fertilizer bills that keep rising, because the biology that used to do that work for free is no longer there. The assumption about native grasses was the second great error and arguably the more consequential one. For most of the 20th century, Australian agricultural extension treated native perennial grasses as weeds to be eliminated. Scrappy, unpredictable, not the introduced ryegrasses and clovers that had been optimized for livestock production. Getting rid of them was progress. Getting rid of them was, in fact, the slow removal of the biological scaffolding that held the entire system together. Their deep roots, their relationships with native soil fungi, their capacity to go dormant and recover, their seed banks that persisted through decades of chemical suppression, all of that was written off as inconvenient competition for neater, more manageable introduced varieties that turned out to be far less resilient when things got hard, which in Australia they reliably do. And the assumption about chemistry, that fertilizer replaces soil fertility, that herbicide replaces ecological management, that pesticide replaces biological pest control, was perhaps the most expensive philosophical error of all. Chemistry is not a substitute for biology. It is a way of borrowing against a biological inheritance that takes decades to accumulate, years to spend, and generations to rebuild. Colin Sayce stopped spending it. The land started saving. The bill, for once, was going in the right direction. The academic community came around, grudgingly and then enthusiastically, the way institutions always do when the data becomes impossible to argue with at a conference. New South Wales Department of Primary Industries began formally documenting the Winona results. Charles Sturt University researchers published peer-reviewed papers. The pasture cropping methodology acquired a scientific literature that followed the farmer, not the other way around. That is a slightly unusual order of events in modern agriculture. It says something worth saying about where the genuinely important experiments actually happen. The expansion word travels differently in farming communities than it does in academic ones. A farmer sees a neighbor's paddock looking inexplicably good and asks what happened. The answer gets repeated over the fence at the next property and then over a beer at the local. By the mid-2000s, pasture cropping had spread across New South Wales not through journals or extension programs or government field days, but through the most ancient agricultural knowledge transfer system that exists. Farmers talking to each other because they can see the difference with their own eyes. Colin and Daryl began running courses. And here is where it gets interesting. Not online courses, not webinars, not certification modules delivered by someone who has never been in a paddock. Actual courses, where actual farmers walked actual paddocks and pushed their hands into actual soil and compared what they felt to the compacted, gray, lifeless clay in their own back paddocks at home. The courses filled immediately. Then they filled again. Then there was a waiting list, which is not a thing that typically happens for Australian dryland agronomy training. It is the kind of waiting list that tells you something real is going on. The methodology crossed borders. Farmers in South Africa, facing their own century of degraded grassland, adopted it. Grain growers in the Canadian prairies, dealing with the consequences of their own tillage orthodoxy, began experimenting with living root systems and planned rest periods. French regenerative farmers incorporated the principles into their systems. American ranchers in Texas and Kansas started reading about a New South Wales sheep farmer who had doubled his carrying capacity by doing fundamentally less to his land. The idea that the land could be a partner rather than a resource to be progressively exhausted traveled because it was the same idea that every degraded dry land farming system on Earth had been waiting for someone to prove. The peer-reviewed literature followed. Studies confirmed the soil carbon improvements, the biodiversity gains, the water infiltration data. Researchers quantified what Colin had been demonstrating empirically for 2 decades on a farm in central western New South Wales with no funding and no institutional support. The science didn't create the movement. The movement created the demand for the science. That sequence, too, is worth noting, and remembering the next time someone says change has to come from the top. What the farmer teaches us. The Winona story is not really about a farming technique. It is about a question that most institutions are structurally incapable of asking, and the rare and valuable kind of person who asks it anyway. What if the problem is the solution itself? Conventional Australian agriculture was not built by foolish or careless people. It was built by hard-working, intelligent farmers and scientists doing their absolute best with the frameworks they had been given. Those frameworks were missing something fundamental. An understanding of what soil biology actually is, what it does, and what it costs in real compounding terms to destroy it. When you don't know something exists, you can't measure its loss. You can't see the earthworms disappearing. You can't feel the mycorrhizal network collapsing. You can't detect the water infiltration rate falling millimeter by millimeter, season by season, until the day you realize the rain is running straight off your paddocks and you genuinely cannot remember when it started doing that. Colin Cease knew the land was worse than it should be. He had grown up on it, walked it as a child when it was already diminished, and carried in his memory the generational sense that something fundamental had gone wrong underneath all the inputs and effort and good intentions. The fire gave him permission to try something different because it removed, in one night, everything he had been maintaining. You cannot reform a system while you are still running it at full capacity. Sometimes it takes a catastrophe to create the space for a question that should have been asked decades earlier. The lesson here is not that everyone should stop tilling and plant into living grass. The lesson is more uncomfortable and more broadly useful than any single technique. The natural system that existed before European settlement was not a primitive version of agriculture waiting to be improved upon. It was a highly sophisticated, self-regulating, self-repairing ecosystem that had been running and optimizing itself for thousands of years. When we replaced it, we didn't improve on it. We took out a very large loan against it, and the bill is what Australian farmers have been paying. In chemicals, in degraded soil, in declining water tables, in failed seasons, in farms sold up and families that didn't make it, for a century and a half. The land wasn't broken. The farming was broken. And one man with a burned paddock, an ecologist who answered his phone, and the particular brand of stubbornness that the farming life either creates or selects for, proved it. Not with a government program, not with a research grant or a 10-year funding cycle or a task force with a logo. With observation, patience, and the willingness to let the land show him what it had always known how to do, if anyone would simply stop interrupting it. Winona Station is still there. The paddocks are still running. The soil carbon is still building. The sheep are still twice the number that conventional management ever sustained on that ground. And somewhere in the grass, the native, perennial, deep-rooted, drought-hardened, 40-species grass that the extension officers once called weeds, the mycorrhizal threads are still connecting everything to everything else. The way they were connecting things long before the first fence post was driven into Australian soil, and long before anyone decided they knew better. We didn't fix the land. We stopped breaking it. That turned out to be enough.